This section is called differential equations, and an equation is called a differential equation if it has a derivative in it. So in this example, we've got the derivative of y with respect to x in the equation. dy by dx is in the equation. So what we want to do is we want to get an equation which just involves, so this is kind of what we want when it says find the general solution. The general solution is going to be an equation involving x and y. And the important thing is it's not going to have, so without dy by dx in it. So we want to kind of get an equation involving x and y, but where it doesn't have dy by dx in it. The method that we're always going to use is called the separation of variables method. And what we're aiming for with this method is all the y's on one side and all the x's on the other side. So we're going to have some function of y dx on the left, dy on the left hand side. So this will be some function of y dy, and then on the right hand side or the other side we're going to have some function of x dx. And the reason why we're aiming for that is because then we can integrate both sides. Integrate the left hand side, integrate the right hand side. The left hand side we're going to integrate with respect to y because we've got dy, and the right hand side will integrate with respect to x because we've got dx. So the first thing that I'm going to do with this equation that we've got is I'm actually going to get dx onto the other side. So I'm going to times both sides by dx. So dy by dx will just become dy if I times it by dx, and then we're going to have x tan y dx. Now the problem with this at the moment is I want tan y to be on the left hand side. I don't want tan y on the right hand side. So I'm going to divide both sides by tan y. So we're going to have 1 plus x squared over tan y. And now we just don't want this 1 plus x squared on the left hand side. So let's divide both sides by 1 plus x squared. So we're going to have 1 over tan y dy equals x over 1 plus x squared dx. So we've met our kind of aim for this method. We've managed to separate the variables. All the y's are on the left hand side, all the x's on the right hand side. And then we're going to integrate both sides, and we need to integrate the left hand side with respect to y and the right hand side with respect to x. So on the left hand side I've spotted that 1 over tan y is cot y. And cot y is a standard integral that we know. We've seen that in a previous section. So the integral of cot in your formula book is log of sine. And in this case it's log of sine y. And the right hand side, we can use a substitution to work this out. So on the side I'm just going to do a bit of side working to work out what this integral is. And I'm going to use a substitution. So I've spotted that the top is related to the derivative of the bottom. And I'm going to divide by the derivative of 1 plus x squared, and that will cancel with that x. So I'm going to let u be 1 plus x squared. So du by dx is equal to 2x. And if I rearrange that, I know that dx is equal to 1 over 2x du. So I'm going to write this as the integral of x over u. And we're going to replace dx with 1 over 2x du. And this substitution has worked because the x's are going to cancel out. So I've got a half times 1 over u. And so that's going to integrate to a half natural log of u. But u is equal to 1 plus x squared, so it's a half log of 1 plus x squared. So let's put that on the right side, a half log of 1 plus x squared. Now, we've gotten our constants of integration, and you don't need to put a constant of integration on each side. For example, you don't need to put one constant there and another constant on that side, because you could just take away C1 from both sides and you'd end up with a constant on the right hand side. So when you use this separation of variables method, all you need to do is stick a constant on one side. I'm going to put it on the right hand side. Now, often the question will say, give it in the form y equals, for example, but in this question we weren't asked for it in a specific form, so we could, if we wanted to, just leave our answer like this.